Hey everyone, it's Mr. Christopher. We're looking at balancing a reaction in acidic solution, and this is a redox reaction. We'll be able to notice that by, first of all, assigning the oxidation numbers. So balancing a redox reaction involves a series of steps. The first step you always want to do is assign oxidation numbers and find out what's being oxidized and what is being reduced. So to do this, the first thing I'll look at here is the oxygen. I know oxygen here is a -2 oxidation number, and there's 4 of them, giving us 8 minus due to the oxygen. And then the manganese has to be a 7 minus in order 7 plus in order for this to be a -1 charge here. And so that gives us a +7 for its oxidation number. The oxygen over here, -2, 8 times that, that's 8 minus. This one, this hydrogen is +1 according to the rules, and there's 2 of those, so there's 2 plus. And then to balance this out, it has to be a net charge of 0 on this molecule, H2C2O4. So it would have to be a 6 plus for the carbon. There's 2 of those, so 6 divided by 2, and that's going to be a +3 oxidation number on the left side. Look at the right side, we got a -2, 2 times that is 4 minus, and that has to be 4 plus. There's only one of them, so that's a +4 oxidation number. Manganese has a 2 plus charge, so that means the whole thing has to have a +2 oxidation number. So now if we look very quickly, we'll see here the oxygens are not changing, it's just the carbon and the manganese. So we look here, the 7, this here is the one going here to the +2, and so its oxidation number is going down, so it's being reduced. And the carbon is going from the 3 here to the 4, so it is the one that's going to be being oxidized. So the next step is to write the half reactions for this particular chemical reaction. So I'm going to write the reduction one first, just because it has the MnO4 ion in it, and that is going to form Mn2+. And then the oxidation reaction is the H2C2O4, and that is forming our CO2. So once you've written down the half reactions, the next step is to balance all elements except oxygen and hydrogen. So look at the top, Mn's good. Look at the bottom, carbon's not good, so I want to put a 2 in front of that to make sure the carbon is balanced here. So I balanced the carbons, that was the next step. So now, next step is to balance the oxygens. So to do that, you add water to the side where you need the oxygen. So I got 4 on this side, so I'd need 4 waters on this side to balance the oxygens. And everything else, that's the oxygens. So now on the oxygens here, I've got 4 and 4, so I don't need to add any waters to the bottom equation. Now to balance the hydrogens, you add H plus ions, or protons. So on the right side I got 8 of them, so I need to add 8 H plus ions here for the top one, and the bottom one I need 2 H plus ions here to balance that out. So now the next step is to add electrons. And to add electrons, the trick here is to make sure you get it so that the electrons allow this to be neutral. So here we had the Mn going to Mn2+. On the left side we got a +8 minus 1, which would be a +7. It's going to a +2. So I need to add 5 electrons up top here to make 5 negative +8 minus 1 equal +2. On the bottom one, I need to add electrons here to this. I've got 2 hydrogens on the right side, no charge, no charge, so you're going to add 2 electrons here on the right side to cancel out that 2 positive charge. Now, once you've added the electrons, the next step is to equalize the electrons in both reactions. So here we've got 5 electrons here and 2 here. So what I'm going to do is multiply the top equation by 2 and the bottom equation by 5. So when the top equation is multiplied by 2, that equals 16. 2 times this. So multiply the top equation by 2. 2 times 5 is 10. 2 times 8 is 16. 2 times 1 is 2 here. 2 times this here, and 2 times that is 8 waters. Bottom equation is multiplied by 5, so 5 here, 5 times 2 is 10, 5 times 2 is 10, and 5 times 2 again is 10. So now we've got both equations with the correct number of electrons that should cancel out: reduction, adding electrons; oxidation, losing electrons, or gaining and losing. And so now the next step is to add these half reactions together. So when we add these half reactions, we look for anything that cancels out. So things that cancel out in this case, let's change the color of the pen to make it more visible. One thing we have that cancels out are the 10 electrons on both sides. Those are the same, so they can cancel out. Another thing we have is we've got 16 hydrogens here, protons, and we got 10 protons here. Now they don't completely cancel, but these 10 cancel out, and that changes that to only 6. So we've got 6 protons on this side. The MnO4 does not cancel, neither does anything else. So next step is to write the 2 MnO4 minus plus the 5 H2C2O4, and that makes 2 Mn2 plus 8 H2O plus 10 CO2. Now this equation here should, if we did it correctly, have the same number of atoms on both sides and the same charge. So I'm just going to check the charge really quick, make sure it works. So that's a positive 6 here, and a negative 2, and no charge. So this equals positive 6 and negative 2 is positive 4. And on the right side, I got 2 times 2 plus is positive 4, and 0 and 0. So the charges to equalize each other, the atoms also should be the same, so we count that up very quickly. 5 times 2 in the hydrogen, that's 10 hydrogens plus 6 is 16. 8 times 2 is 16. The hydrogens are equal. 2 Mns, 8 O's here plus 20, so it's going to be a total of 28 O's. And so there's 20 plus 8, 28 O's. So this equation is balanced in number of atoms and charge, and we are done.